Hey third graders, it's Mrs. Seals back for our third science lab of the school year. We are still talking about physical properties. Hopefully you remember that these are ways we can describe objects such as color, size, shape, texture, temperature, all of those things. Last week we talked about the physical property of temperature, which remember means how hot or cold something is. Today we're going to be talking about another physical property, which is the ability to sink or float. And I'll explain more about that in just a second. So your target says I can measure, test, and record physical properties of matter, including the ability to sink or float. All right, so let's get right into it. Sink or float, and there's your target again. I can measure, test, and record physical properties of matter, including the ability to sink or float. What does it mean to sink? When something sinks, that means it falls to the bottom when placed in water. The water cannot hold it up. So here's a picture of a rock in a glass of water, and the rock sinks to the bottom. The water is not able to hold the rock up. What does it mean to float? When something floats, that means it stays on top of the water. The water is able to hold it up. Here's a picture of like a rubber ducky that you would maybe have in your bathtub, and it is floating. It's sitting on top of the water. The water is able to hold it up. So what determines whether something will sink or float? So what you're going to do in just a second, you're going to pause this video, you're going to go back into Schoology and find the discussion post question and create a post telling us what you think. So what do you think determines whether something will sink or float? Or in other words, what makes the rock sink, like we just saw in the picture, and what makes the rubber ducky float? Okay, so pause the video, go ahead and do that, and then come back. All right, see you in a second. All right, so what determines whether something will sink or float is this word density. Can everybody say density? Good. So whether an object will sink or float is determined by its density. And density has to do with an object's mass, which hopefully you remember mass is how much matter is in an object, and the volume, which means how much space the object takes up. When you get into middle school, you'll actually learn a formula to calculate density, where you measure the mass of the object, you measure the volume of the object, and you divide those numbers, mass divided by volume, and that gives you a number to represent the density. You don't have to know all of that right now. All you have to know right now is that the mass and the volume determine the density. Okay, so in other words, how much matter is in an object and how much space it takes up. All right, if something is less dense than water, it's going to float on top. If something is more dense than water, it's going to sink to the bottom. This last part is very important because a lot of people think that whether something sinks or floats is determined by its weight or how heavy it is. It does not. Weight does not determine whether an object sinks or floats. A good example of this is a boat or a cruise ship. They are very, very, very big and very, very, very heavy, but they float. Okay, it does not have to do with weight. It has to do with mass and volume. Make sure you understand that. That's very important. How much matter is in an object, how much space it takes up. All right, so we're going to do some practicing with this today. And we are going to be looking at some different objects. I think there's 10 of them. And we're going to be seeing which ones sink and which ones float. All right, for each one, before I test it out, you're going to make a hypothesis and a prediction to think about whether you think it will sink or float. All right, and we'll talk about these. So, of course, in order to do this experiment, I have to have water to put the object in, right? Okay, and then, I wonder if I should raise it up, if that would be easier for you to see. All right, and then we're going to test out 10 different objects. All right, so the first object we are going to test out, and let me preface this and say, this is an experiment where it would be much better for you to understand if you were here in the science lab and you could touch these objects, you could hold these objects, you could think about the things I just told you to make your hypothesis and to understand why they sink or float. But we're doing this virtual school right now, so we're just doing the best we can, okay? I know that it's hard for you when you can't actually touch and feel these objects. I will do my best to describe them, and we're just doing the best we can, all right? So the first object we're going to test out is a ping pong ball. So a ping pong ball is very light. It bounces very easily because it's hollow inside. What that means is there's nothing inside of it except air. Okay, so think about when I told you that the density is determined by how much matter is in an object and the space it takes up. So go ahead and make your hypothesis. So in other words, I want you to tell me or show me if you think the ping pong ball is going to float on top of the water. Give me a thumbs up. Our thumbs up will be float. If you think the ping pong ball is going to sink to the bottom, give me a thumbs down. So thumbs up for float, thumbs down for sink. All right, are you ready to find out? I'm gonna carefully set it into this tub of water. And, ooh, our ping pong ball floats. Good job. Most of you were exactly right. The reason our ping pong ball floats is, like I told you, it is hollow inside. There's nothing inside of a ping pong ball except for air. And so that causes it to float on top of the water. We could say that it is less dense than the water. All right, ready for our next object? Our next object is an eraser. All right. So again, I know you can't touch it and feel it, but it's just like a normal eraser that you would use here at school. Think about what would be inside of this if we were to cut this open. Do you think there would be a lot of matter inside, or do you think there would only be a little bit of matter inside? All right, so again, show me if you think the eraser will float. Give me a thumbs up. If you think it will sink, give me a thumbs down. All right, let's see. Ready? Oh man, it sunk really, really fast, didn't it? Good job. So the eraser sank to the bottom. That's because there is a lot of matter inside. The molecules are very tightly packed. If we were to open it up, it would not be hollow like the ping pong ball. All right, our next object is a pencil. Make your hypothesis. If you think the pencil will float, thumbs up. If you think the pencil will sink, thumbs down. All right, let's find out. Ready? The pencil is floating. Oh my goodness. Did you think the pencil was going to float? Some of you might have thought the pencil was going to sink because if we cut it open, there's stuff inside. There's a lot of matter. However, pencils are made of wood, and wood is a material that floats. because even though there's stuff inside of it, it's not very tightly packed like some other things like rubber, okay? So wood always floats. Pretty cool, huh? That's why a lot of times if you go to the lake or a river or even the ocean, a lot of times you'll see branches or sticks or big parts of trees floating on top because they're made of wood and wood floats. All right, ready for our next one? Our next one is a straw, like a regular straw that you would drink out of. So think about, does it have a lot of tightly packed matter inside, or is it more hollow? Can you see through there? Let's see. Oh, hi, you can see through, right? There I am. So that means it's pretty hollow. So make your prediction. Is the straw going to float or sink? All right. Ready to find out? The straw is floating on top of the water. Yep, the straw is hollow inside. There is not a lot of tightly packed matter. It's pretty much just filled with air, so it floats. Good job. All right, our next object is a marble, a glass marble. Again, I know you can't feel it and touch it. Think about glass. Think about what this would look like. It is not hollow. If we were to cut this open, it would be filled with tightly packed matter of glass. All right, so show me. Is the marble going to float or sink? All right, most of you say sink. Let's find out. And it sinks. Yep, glass is a material that sinks because the matter inside is very tightly packed. It has a lot of mass. All right, good job. We have a couple more. Let's see what else. We have now a piece of styrofoam. So this is what we call a packing peanut. It's not like a peanut that you eat. It comes in like a box. If you order something online and it's being sent to you and it's something that is breakable or fragile, they will put a lot of these in the box to help protect it. It's very squishy. It kind of acts as extra padding. It's made of styrofoam. All right. It's very, very light. The matter is not tightly packed. So do you think it's going to float or sink? Float or sink? All right, lots of floats. Let's see, ready? And it floats. Yep, styrofoam is a material where the molecules inside are not tightly packed, so it floats on top of water. Good job. All right, our next one is a golf ball. So golf balls, it feels a lot heavier than the ping pong ball. It is not hollow inside. If we were to cut it open, there would be stuff inside there. So the matter, it has a lot of mass. It has a lot of matter inside of it. All right, make your prediction. Is the golf ball going to float or sink? All right, let's see, ready? The golf ball sinks. Yep, it has a lot of tightly packed matter inside. We could say that it is very dense. It sinks to the bottom. All right, our next one is what we call a craft stick, or you might have heard it called a popsicle stick. So these are made of wood. Think about what we already talked about with wood. Make your prediction. Is this going to float or sink? All right, you ready? And it is floating on top. Yep, it is made of wood. If you were listening, I told you that wood is a material that floats. Good job. All right, our next one is a piece of a sponge, like you would use to clean your kitchen or your bathroom or something, okay? Piece of sponge. Think about sponges. They're squishy. They're not tightly packed. There's a lot of air or space inside of them. Do you think that this is going to float or sink? All right, ready? Here is the sponge, and it is floating on top. Yep, sponges do not have a lot of tightly packed matter, so they don't have a lot of mass, and they float. All right, a couple more. Here is a paperclip. See the paperclip? Paper clips are made of metal. Is it going to float or sink? Paper clips are very light. All right, let's find out. Are you ready? Did you see that? The paper clip sank to the bottom. There it is on the bottom. Wow. Did that surprise you? Did a lot of you think that the paper clip was going to float? I bet a lot of you thought that the paperclip was going to float because it is very small and very light, and inside of it, there are kind of these bigger holes. However, paperclips are made out of metal. Metal is a material that is very dense. In other words, it's very tightly packed, okay? If we were to cut it open, it wouldn't be hollow inside. The matter would be very tightly packed inside of there. So even though this paper clip is very small and light, it still sinks. That's why I need you to understand that the weight of an object does not determine whether it sinks or floats. Okay? It's determined by its mass and how much matter is packed inside of it, and its volume, or how much space it takes up. All right, so the paper clip sank to the bottom. All right, three more. The next one is a bead, like some people wear in their hair. You might do a craft or art activity with it. A little plastic bead. All right, do you think it's going to float or sink? Float or sink? All right, let's find out. Ready? Whoa, look at that. The bead is floating. Interesting, huh? It's on top of the water. It's less dense than the water. Plastic is a material that it depends. Sometimes plastic sinks, sometimes plastic floats. It depends what type of plastic. It depends how the plastic was made and how tightly it's packed. All right, but this bead, since it is small and not tightly packed molecules, then it floats. All right, two more. This one is a rock, just a regular old rock. Think about the things I've already shown you previously in the PowerPoint. Is it going to float or sink? All right, ready? Ooh, it sunk fast, didn't it? Yep. Rocks are materials that are very, very tightly packed. If we were to cut this open and look inside of it, it would not be hollow. There would not be space or air. It would be full of matter. It has a lot of mass. So rocks sink to the bottom. All right. And our last one is a toothpick. It is made of wood. Think about what we've talked about with wood. Is it going to float or sink? All right, ready? The toothpick floats. Yep, it's made of wood. I've already told you 2 times, wood is a material that floats because it does not have a lot of mass. The matter inside of it is not tightly packed. All right, so that was our experiment on sink and float. What you are going to do in just a second when this video is over is you're going back into Schoology. There is a short quiz about sink and float. It's just 5 questions. It's not for a grade. It's not required. It's just for me to see what you learned about sink and float. I want you to do your best, okay? If you forgot the answer to any of the questions, you can go back and watch this video again as many times as you need to help you with the answers, all right? Hope you guys enjoyed that, and I'll see you next time. Bye-bye.